Let me get rolling with this. All right, today we're going to talk about perpendicular and angle bisectors, or how can you describe a set of points equidistant from points of second or from the size of an angle? We'll talk about all that in a second. Prove and apply theorems about perpendicular and angle bisectors. You need to know equidistant and locus. Let's start off with equidistant. When a point is the same distance from two or more objects, the point is said to be equidistant from the object. What is my prefix in that word? Equal. What? Equal. Equal. What do you think equal? Equal. Yeah, equal, right? Okay. So notice the key right here. Equal. Okay. Write down what I've got in red. Be okay. Triangle congruence theorems can be used to prove theorems about equidistant points. Okay. That'll help us get to this definition. Locus is what we call a set of points that satisfy the condition. Okay. So whenever we're talking today about perpendicular and angle bisectors, that word equidistant is crucial. Man, she makes they have to say I'll just right? Yeah.
They have this bag of cheese.
No, it's right.
You get cheese, you get cheese and vegetables. I need a fork. Can I go get a fork? I need a fork.
All right. We have what we call the perpendicular bisector theorem and the converse of the perpendicular bisector theorem. So, perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. The converse just says the opposite. If a point's equidistant from the endpoint of a segment, then it's the perpendicular bisector of a segment.
Wait, does that mean you would call it Alabama for a sandwich? Yeah. Are you?
It's that good.
I would like to hear what I love Panera Bread. I have this really good, like, I never think like Christmas gifts, you don't really your dad is big.
My first year here, I gained 30 pounds.
And they have bacon.
Some of that was my wife.
She could like, nah. My dad makes it. He makes the mac and cheese. The whole thing.
All right, let me point out a couple things, guys. First off, line segment XY is the perpendicular bisector of line segment AB. Two things you need to always remember about a perpendicular bisector. Forms a 90-degree angle, cuts a segment into two congruent parts. Okay? 90-degree angle cuts a segment into two congruent parts. When we provide it because we are going to apply it, we're going to know it. We're going to learn it. Okay? What this theorem says is that when that is the case, the distance from XA and XB are congruent. Or vice versa, if the distance from XA and XB is congruent, then XY is the perpendicular bisector of AB. Okay? What kind of angles do we form? Right angles. And what else does the bisector do? Okay. Any more time? more seconds here.
I need a fork. I may do my hands.
I noticed. All right. Oh my God.
What's she eating?
Oh, look up here. Let me show you how to apply this. Okay. It's really today's work's really easy. Okay. It's really easy. It should be easy. If I'm trying to find the measure of B to C, okay, here's what I know. I know that AB and AC are congruent, right? Because they're both 38. Look at how I do this problem. If those are congruent, then AD is the perpendicular bisector of BC. If this is the perpendicular bisector, it's got my 90-degree angle, and it means that these two segments are congruent to each other. So if this is 12, how much is this one? So what is B to C? 4. Right, 12 plus 12. You got me? Just some simple. You gotta apply that theorem and then add. Yeah, it's kind of like what we were doing the other day, in a way. Okay. Here I'm given that UW is the perpendicular bisector of TV. So that means that U to T would be congruent to U to V. Speaking of UT, is anybody a water pen in here? Good deal. Good deal. Okay. All right, so here's what I do. It says find the distance from T to U. First, I've got to find my value for X by setting 3X plus 9 equal to 7X minus 17. I'll solve for X. I do all this work for you right here. Solve for X, plug X back in to get my answer. Okay? But once I find out that that's the perpendicular bisector, it means that those outside parts of this triangle are congruent. Okay? Angle bisectors. For some reason, this is a little bit harder for first block to see, but it's okay. There's some morons in there. There's some good people. There's morons too. Real quick, let's talk what an angle bisector does. An angle bisector, remember, an angle bisector cuts an angle into two smaller congruent angles. So PC, ray PC in this example is the angle bisector. It takes angle APB and cuts it in half, right? Correct? Yes, ma'am. All right. So think about like when you got a pizza, okay? You got a pizza, and your teacher comes along, he's like, hey, can I have half of that? You're like, sure, I'll cut exactly half of that for you. You would find the angle bisector to cut that pizza in half. Okay? All right. But here's what else this angle bisector can do, okay? Any point on that angle bisector would be congruent to, it's called equidistant. So equidistant from each point on the angle. Okay? In this case, AC would be congruent to BC. Notice what else is true about the angle bisector. What kind of angles does this form? Right angles, okay? The right angle there. The converse is true as well. If CA and BC are congruent to each other, that means that PC is the angle bisector, and the angle APC is congruent to BPC. Look how easy this can be. It tells me that, well, how do I know on this drawing, how do I know that AC is the angle bisector of BAB? What gives it away just based on the diagram? These two things right here. You see those little lines? Those lines give it away. Okay? So if it's the angle bisector, then any distance from C to D would be congruent to any distance C to B. So what is this distance going to be? 7.2. bisector theorem. Ooh, look at this one. Find the measure of EFH if EFG is 50. Okay, first off, notice that H to E and H to G are congruent. That should signal for me. That means that that is a angle bisector. Yep. And if it's an angle bisector, it means that EFH and GFH are congruent. If one of them's 50, the other one's 50, 50 plus 50. I'm sorry. If the big one is 50, then cut in half. The little ones would be 25. You got to go the other way with it too, though. Okay, y'all work this problem out. Okay, take about a minute. If you don't want to write it down, don't write it down. I'm not going to be too picky on it. I promise I'll give you plenty of work. Douglas. Okay, given that the measure of angle WYZ is 63 degrees, so I'll help you out here. WYZ is 63 degrees, and that XW is 5.7, and ZW is 5.7. Find the measure of angle XYZ, which is a one-step problem. I'll come to you in a second, Brady. 63 degrees. Okay. Brady, what'd you get? How did you get 126? How do you know that they're congruent? Okay. So what you're missing is this. If WX and WZ are congruent, then WY is the angle bisector of XYZ. And if it is the angle bisector, this angle, WYZ, is congruent to angle WYX. So both of these would be 63, which means that you can add 63 and 63, or you can take 63 and multiply it by 2, and you should get 126 degrees. That's what okay. Told you, it's pretty easy, right? Very simple, straightforward today. Okay. All right. Wow, check this guy out. Here's your real world application, just in case you're ever jumping out of an airplane and parachute. S is equidistant from each pair of suspension lines. What do we conclude about QS? It's the what? So look where S is. This is why this is the tough one. S is right here, correct? Would it be the angle bisector? No. It would be what? Right. If it's not the angle bisector today, it's probably going to be the perpendicular bisector. Okay. All right. Last thing. Okay. Write an equation in point slope form for the perpendicular bisector of the segments within points C at 6, -5, and B at 10, 1. First thing to do is to graph that segment. Okay. And then check out what we want to do. We want to find the midpoint. You do not have this in your notes. You need to write it down right now. Your midpoint formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2. You come to me later today and you say, Mr. Hobbs, what does that ask me to do? And I say, find the midpoint. You say, okay, how do I do that? And I say, midpoint formula. Don't ask me, what is it? Okay, go to your notes. Look up where you wrote down midpoint formula. And plug in our coordinates. Okay. So in this case, x1 was 6, x2 was 10, y1 was -5, y2 was 1, 6 plus 10 is 16, 16 divided by 2 is 8, -5 plus 1 is -4, -4 divided by 2 is -2. So my midpoint is at the point 8, -2. Midpoint formula. Better roll off the tongue. Okay. Then there is the second part. Remember, we take the midpoint, we find the midpoint, and then we find the slope. So once again, make sure in your notes you have this called the slope formula. The change in y, y2 minus y1 over divided by the change in x, x2 minus x1. Same numbers I just used for midpoint, plugged in different places. Okay, so 1 minus -5 is 6, 10 minus 6 is 4, 6 over 4 is simplifies to 3 over 2. When you get to that point, stop and look up here at me because I know that you're ready for the key lesson today, key point in today's lesson. Okay. All right, here is the key point. When you find the slope, to find the perpendicular part, or the perpendicular line, you take the opposite reciprocal of your slope. That's how you form 90-degree angles. You take the opposite reciprocal. When I say opposite, go from positive to negative, or go from negative to positive. When I say reciprocal, you will switch your numerator and your denominator. So my opposite reciprocal slope of 3 over 2 is -2 over 3. What would be the opposite reciprocal slope of 2? See, take 2 over 1, take the reciprocal, which is 1/2, the opposite, which is -1/2. Okay? Now it's okay, it's going to happen many times, it happens. And many times. Alright? That's how I find my perpendicular line. That's it. We got any questions about that? Okay. I'll give you guys your